Hey there. We're going to go ahead and finish out Chapter 6 here. We're going to talk about exponential growth and decay. We're going to use the same compound interest, continuous compound interest looking formula because it actually is derived the exact same way. And A naught, or A sub 0, is going to be our initial amount, and A of t is going to be our final amount after a certain amount of time. Now, I want to talk a little bit about half-life for a second. Half-life is assigned to an element that is unstable and is radioactive. And when you have a radioactive element, what that means is that the nucleus is unstable and it's releasing energy in a couple of different forms. And over a certain amount of time, the nucleus of the atom will actually fall apart and become different atoms altogether, or different elements altogether. What a half-life is it's the time that it takes for a certain amount of radioactive element so that there's only half of it left. So, for example, let's say there's a radioactive element that is 100 grams. Well, after the time duration of a half-life, we will then have 50 grams. And after another time duration of time, of a half-life, then we will go from 50 to 25. And another half-life is going to drop it down to 12.5 grams. So each one is dropping it down by half, exponentially. That's for half-life. We also use this for bacterial growth, compound interest, population growth, and things like that. When we say population, we don't mean people. This doesn't work so well with people. Much more complicated models are usually used. So let's start with half-life, after what I just explained. And if the half-life of a substance is 8,800 years, then how much will be left after 1,000 years if the initial amount is 3 grams? Well, the first thing we don't have is the rate, R. So I'm going to start with 3 grams, and after its half-life of 8,800 years, I will only have 1.5 grams. Well, that works perfect for me because I can just plug it into the formula, and the only unknown that I have is R. So I divide both sides by 3, which reduces to a half. Take the natural log of both sides. That brings the exponent down, and that just becomes 1. Then I divide both sides by 8,800. And it gives me this big funky number here. Then what I do is I take that rate and I plug it back into the original equation, where A naught is 3. And I want to know, after 1,000 years, how much will I have? Well, let me show you where we're getting these numbers from. This is going to be second ln for E raised to the negative 0.1234 zeros, 7876672 times 1,000. Be careful. Mine is a little bit newer, and I don't need to put parentheses here. Yours, you may need to put parentheses. That may be a must. So I'm going to hit equals, and then times 3. And you can see it dropped down to 2.77 grams. Make sure you practice this with your calculator and see if you get those same numbers. Next, we have a colony of bacteria increases according to the law of uninhibited growth. What that means is we put it in a nutrient-rich medium so that at a constant temperature and pressure so that it's optimal for the bacteria to grow. This is done all the time in labs. And we're going to start with if the number of bacteria doubles in 5 hours, sort of like a reverse half-life, find the function that gives the number of cells of the culture. So when we double it, that means we take our initial population times 2. So that becomes our A in our formula. And you'll note I can divide the P out. I put in 5 because it's 5 hours. I take the ln, and that brings the exponent down. That goes to 1. And divide both sides by by 5, pardon me. So here's my rate. I take that rate and I put it back into the formula. We're here. And what I'm going to do now is I'm going to use this formula for part B. So let's put this like, let's see if I can put the whole thing together. There it is. So I'm going to be using this formula. Part B, it says if there are 10,000 cells initially, how long will it take for there to be 25,000? So P is 10,000, A is 25,000. R we have here. So we plug it all in, and you can see we're going to solve for T. It does say for how long. What is T? Dividing both sides by 10,000, I get 25,000 over 10,000, which reduces to 5/2, equals this here. And what I'm going to do now is take the natural log of both sides, and that brings the exponent down, and that turns into a 1. And then I divide both sides by that. Now this gets a little tricky. I'll show you how to do that. So we're going to go natural log of 5 divided by 2, and close the parentheses, divided by, parenthesis. Now, be really careful with the parentheses here. ln of 2, close parenthesis, divide by 5, close parenthesis. You will definitely need to practice that, and that gives us our 6.61 hours. Hope that was helpful.